All right, now let's get these questions. A bag contains 7 red blocks and 3 green blocks. A block is selected at random, then replaced in the bag. A second block is selected. Find the probability that 2 red blocks are selected. So how many events are taking place here? 2 events are taking place. If it is 2 events, we always draw a tree diagram. So let's draw a tree diagram here. In the first event taking place, the possible outcome 7 red blocks. Let's write it. Let's write on the side. Say that we got 7 red block and what is it? And 3 green blocks. So okay, this is red and green. Then afterwards, this is the first row. In the second row, if the first is red, second can be red and green again. First is green, second can be red and green again. So this is the second row. That's a very important phrase here, replaced. If it is replaced, things are different. If it is without replacement, things are different. Here, after the first row, it is replaced. Then, first of all, in the first row, what is the probability of getting a red? Probability of getting a red will be 7 out of 10 because there are altogether 10 blocks. 7 is red. And green is 3 out of 10. And when you draw the first block and you replace it, and in the second row, still we have 7 red and 3 green. Then what is the probability of having a red? Again, 7 out of 10. And having a green? Again, 3 out of 10. If first is green, second will be 7 out of 10. Green will be 3 out of 10. If it was without replacement, then number of blocks will be in the second row. Number of blocks will be 1 less. This will be not 10 but 9 because 1 block is already drawn here. If it is without replacement. But this is replaced, so nothing has changed. Okay, 2 red blocks are selected. So what is the possible outcome? The first thing is I write the possible outcome. The possible outcome should be red and red. So we go to the branches and we check red and red. So it's going to be 7 out of 10 times 7 out of 10. The answer will be 49 out of 100. A red and a green block are selected. So what are the possible outcomes? A red and green. So it can be RG or it can be green and red. G and R. Okay, what is RG? R is 7 over 10 times G is 3 over 10 plus G is 3 over 10 times R is 7 over 10. Never simplify during the multiplication. We just write the common denominator 100. It's going to be 21 plus 21. So that's going to be 41 out of 100. Now simplify. It's going to be 21 out of 50. All right, the third one. At least 1 green is selected. Let's answer it here at the bottom. At least 1 green is selected. What are the possible outcomes? Can it be red? Cannot, because it should be at least 1 green. It can be 1 green, it can be 2 greens. RR cannot, but it can be R and G, or it can be G and R, or it can be G and G. If you look at these possible outcomes, you will see that we have at least 1 green in these possible outcomes. So what is RG? RG is what is it? R and G, 7 over 10 times 3 over 10 plus it can be green R, 3 over 10 times 7 over 10 plus 3 over 10 times GG, 3 over 10. If I write common denominator 100, so that will come 21 plus 21 plus 9, it can be what? That is 30, 51 over 100. So the answer is 51 over 100. All right, let's look at the second question. A coin is tossed 3 times. Find the probability of. If the question is about tossing coins, absolutely you will draw tree diagram. In the first toss, it can be head or it can be tail. In the second, again, it can be head and tail, again, head and tail. And the third, it could be head and tail, it could be head and tail, it can be head and tail, and it can be head and tail. What are the probabilities of that? We have to write the probabilities on the branches. So the first row, having a head is 1 over 2, having a tail is 1 over 2. In the second toss is again 1 over 2. Nothing will change because each time you toss a coin, the probability of having a head is 1 over 2. Probability having a tail is again 1 over 2. Nothing will change. It's going to be the same probability. Now, 3 tails. What is the possible outcome? It can be T t, and t. So 1 over 2 times 1 over 2 times 1 over 2, it can be 1 over 8. Two heads, one tail. What are the possible outcomes? HHH can, cannot. HHT can. Two heads, one tail. Or can it be HTH? Yeah, of course. HTH. Two heads, one tail. It can be HTT? No. It can be THH? Yes, it can be two heads, one tail. It can be THT? No. TTH? No. TTT? No. Okay, each time probability will be 1 over 2 plus 1 over 2 times 1 over 2 times 1 over 2 plus 1 over 2 times 1 over 2 times 1 over 2. So it makes 1 over 8 plus 1 over 8 plus 1 over 8. That could be 3 over 8. At least one tail. At least one tail, you can answer it in two different ways. So the first way is, let's write the possible outcomes. At least one tail, it could be HHT. It could be HTH. It could be HTT. It could be THH. It could be THT. It could be TTH. It could be TTT. If you look at all these possible outcomes, you will realize that there is at least one tail. It could be one tail, it could be two tails, it could be three tails. Each of them is probability 1 over 8. 1 over 2 times 1 over 2 times 1 over 2. I'm not going to rewrite it again. So we got 7 1 over 8 here. 1, 2, 3, 4, 5, 6, 7. So that makes 7 over 8. The second way is, there is only one possible outcome which doesn't have a tail. That is HHH. If I take away probability of that from 1, because maximum probability is 1, so I will get the probability of at least having one tail. So 1 minus, what is probability of HHH? 1 over 8. So the answer is again 7 over 8. You can answer it two different ways.